uh, for our next presentation, we have Landon from Canton. He's part of the uh, Lightning Robotics team there, and he's going to showcase what he and his team did with Inspire. Landon, I don't want to take away any of your thunder, so please, share your screen and
Yeah.
show everybody what you accomplished.
Turning on the system real quick.
All right, and for the sharing your screen, you should see it on the top ribbon.
Yeah, my computer is trying to get access to it, so that's what I'm working on.
Always the first time that is takes a couple minutes to download. But if you like, you can start by introducing yourself. And
is that working? Perfect.
Yep, now I see it.
We can see it great. Fantastic.
Okay. Hi, my name is Landon Cooper. I am the design lead of 862 Lightning Robotics. This is my third year on the team. I am a junior in high school. I'm going to go over how my team used Altair and how it's improved our experience with robotics and improved the robot. So one of our biggest problems this year was our collector 2x1 bending. You can see it on the side here. There's a blue highlighted spot where
your slide didn't change yet. The first slide.
For me, is it just slow?
It still shows you the first page there. Here we go.
That work?
Yep. Now we see the problem.
Okay. So our biggest problem this year was the collector 2x1 bending, as I said. And when it would bend, it would push into some of our active components in the robot that would move our game piece into the shooter. And when it was bent in that way, it couldn't support the bumpers and it would block our note path, which caused us to lose matches and have to replace it quite often. And I'll go more into here's a quick video of us hitting the stage and breaking that 2x1. And so here is here's what happened due to that hit. You see how it's very bent and more than it should be. So we had to swap it every time that happened. And it happened numerous times through multiple competitions. It requires a lot of pit crew time to swap either just the rail or the whole collector. And while we're at a competition, we don't have time to cut a new 2x1. So we have to bend it back into place if we want to try and reuse it. But as you know, bending metal back and forth can cause it to fatigue and bend more easily. So we just had to find a better solution and a way to stop that bending. Our idea was a weight to strength cost analysis. We wanted to see which method would give us the strongest rigidity with the least weight, because we were very close to the weight limit at the time. And I tried 6 different options. There's 2 main shapes. It was a flat plate along the bottom or a right angle bracket along the corner. And we tried different thicknesses to see how thickness and weight would affect it. And we used Altair Inspire to see how it would displace it with our variables. So testing, our control was we put 150 pounds on the face that was flush to the bumper, trying to recreate the force you would see when hitting another robot or a wall. Our material was aluminum, as the 2x1 was made out of that. And the data we were collecting was maximum displacement. While the test we were running probably wasn't 100% accurate, it was more of a comparison to see how do these two things under the same force react. And there's a lot of data there, but it's easier to see it when it's put into a graph like this. And you'll see I broke it into 3 different spots. There's L brackets, flat plates, and no support. You'll see on the far left, the L brackets, those had the strongest weight to displacement, while the 1/4 inch L bracket weighed the most. It also had the least displacement. And then the 1/8 inch L bracket weighed the second or third to most, but it had a super low displacement, while the flat plates, the quarter-inch variant did weigh a little bit more than the L angle, but it had more displacement, meaning it moved more under that impact. You'll see all the flat plates, it's pretty linear how the thickness affected the displacement. And you see the yellow column is just how it reacted with no support at all. So we basically like not half, but like 2/3 of the movement it was having before. So our final choice was the L bracket that was 1/8 inch thick. We made it as wide as possible for the most surface area covered, so it's the whole width of the robot. It was fully made in 2 days because we already had the stock ready, so super fast solution. This was done in between competitions between states and worlds. We only had a day or two to make these, and then we had them mounted in the same day we had them finished. And they survived countless impacts. We only had one bend slightly, and that was because of a big impact with another robot. But 3 out of 4 of our 2x1s with the left bracket did not bend. And you'll see in the middle there, that's the photo of the bracket on the robot as it is now. You'll see the cat at the top and then our drawing that we used on the side. Yeah, so our challenge was a box tube that holds our bumper and supports our collector, keeps bending from impacts. Our solution, we used Altair Inspire to test many different ideas and thicknesses to find the best option. We used a analysis system of weight to strength to see which would be the best option. And this saved us a lot in a lot of testing, where having to try doing this physically probably wouldn't have given us as accurate results. We would have taken more time to test the different ideas, and more often than not, probably would have been unable to recreate the bending because we don't have other robots to run into, don't have a stage to run into. And so, yeah, Altair saved us hours of time and improved the robot very fast.
All right, excellent, Landon. Right now, this is a time for questions. If anybody in the audience would like to ask Landon a question about what he did here, the challenges he had, or surprises he had, that'd be great.
There's
Right,
looks like
Ben.
Ben has his hand. Yeah, there we go. Okay.
So,
Yeah, they can unmute themselves. Ben, if you want to unmute yourself and ask a question.
Okay. How long did it take to run the strength to weight analysis?
Each test took about 5 to 10 minutes to get the variable set and the parts made in the CAD software. And then the actual time I pressed run the system of testing was about 1 minute to 2 minutes of load time.
Thank you.
all right. Omar, I think you had your hand up.
Yeah, I was gonna ask the same question.
Yeah. Well, and it's and again, it's a great question. What you'll find is with our tools in general, they're really optimized to work well on laptops and standard equipment. While these are high performance, solvers running behind the scenes, Altair prides itself on trying to make sure that these tools can run as effectively as possible, because part of our motto is we want people to do endless amount of simulation, and to do that you need to be able to do it fast. And actually Eric is probably going to talk a little bit about that in his presentation too. So good.
Don't tell them my secrets.
I know. Yeah. Well, they won't be after you talk. So great. Ian.
Where along did the bend occur after the bracket was installed?
Same location right in the middle, because that was the most unsupported spot of the 2x1.
Thank you.
Yeah.
Well, again, the other thing I just wanted to point out is, by you able to do this, besides saving time, it saves material and cost. I know that's not the most expensive probably piece on your robot, but every bit is a cost that you guys have to cover one way or another.
Yeah, this late in this season, money starts to become a big want when you want to buy new stuff for the next season.
So true. Samuel, I see you have your hand up.
Yeah, does the software allow you to simulate kind of forces at different points along the piece, or just towards the center of the piece in general? Obviously, the center would be the most vulnerable, as you said, it's the least supported. But can you simulate impacts or forces on other parts of the piece as well?
Yeah, it seemed
Absolutely.
like there were a few options with that, where you could choose a radius of impact and then a location along the part you're hitting.
Yeah, perfect, thanks.
Yeah, and just to add to that, if you picked any point on that structure, you could have found what values, how much deflected, stress amounts and so forth, other information. But as Landon said, since the impact, that was the least supported area, and that was what they wanted to look at, the worst case scenario. That's what they focused on. A great question. Any others for Landon here? Landon, I wanted to ask, how were you motivated to use Inspire? I mean, you're again, while you're a local team, before I saw you at Worlds, I have not talked to your team personally, so I was just curious how it came about.
So we saw a lot of the things Team Hot did with Altair and the cool animations they made of the robot under motion. And then our team right now uses Fusion. We hope to switch to Onshape. But Fusion has a built-in simulation software that can take up to a half hour per simulation, as well as Onshape not having a built-in one without having to pay or download extra stuff. So we saw Altair as a free choice for students. It was tested by a team that we saw as really good, and we're like, hey, this team's good, it's free, let's test it, and it works really well for us.
Excellent. And again, it's great that you're able to find that information. And that kind of goes to something else, what we would like to do, or ask all teams to do, is when you have a success like this, it would be fantastic if you can share it in Chief Delphi. We can only reach so many teams. And in this is a perfect example of how Hot team was able to, help others and part of the whole cooperation with all the other teams that are participating. So, so when you do use our tools and have some great success, please post it on Chief Delphi too, and let other people enjoy and the ability to do things like this, because not just for first, but for your future, and if you're going to college or something like that, that's a good thing to be able to brag about. So again, thank you, Landon. We're at the pretty much with 1 minute left here, but I think this is probably perfect time to switch over to Eric, because I know if I ask another question, we'll go over. So again, thank you so much, Landon.
Yeah, thanks for having me.